All right, everybody, good morning. Welcome to week 4 of CNET58. This is the start of the quarter point, right? Where we're a quarter of the way done with the course. So after this week, we'll be a quarter of the way done. So I'm just going to kind of watch the participant list, see if anybody needs to be added to the meeting. And so if you, there we go, there's 2. So how are you guys doing? Everybody doing okay?
I'm doing great. Just the time chain's a little weird.
Yeah, doesn't that the one in the spring is the hard one for me, losing an hour of sleep. I think it's psychological. Yeah, everybody else okay? Yeah, still tired from the time change. Everybody's good. All right, good. Well, today we're going to look at in more detail, kind of from a higher level, maybe a top level down look at some of the features that are built into VMware's vSphere. So let me open up today's lecture notes, which again, these are on Canvas, so you'll be able to get to them just like I can. And actually, let me share the lecture notes here. All right, so can you see the PowerPoint there?
Yes.
Yeah, okay, good. All right, so let me let it render it. And this meeting is being recorded. So if there's any information you need to come back to, you can always come back to the video, which I'll post on Canvas after I get the recording back from Zoom. So today we're going to kind of take a top level view of VMware's vSphere. And then in today's lab, we're going to continue building out our environment with a specific focus on routers, right? Now, so far, our 3 VMs we have built are going to be used as our parent VMs. So from those parents, we will clone the multiple children that we're going to need for other functions in our network. And today, those functions will be a CentOS child VM will be created for a router and using the firewall D service. And then in Windows, we'll create a child VM that will make a router using the remote access and routing function, so the RRAS in Windows Server. Okay, so with regards to VMware, see here, when we look at VMware, and again, VMware's vSphere product line is the #1 seller in the market for virtualization. So when you're talking about virtualizing and you're a larger company, you're probably walking into a VMware environment. I mean, that's just kind of the way it is. So when you use VMware, you want to ask yourself, what's in it for me? Why should we virtualize? What are the benefits? And then what exactly are all the parts that come with VMware? And as we're going to see today, we are working with a little tiny portion of VMware, which is the hypervisor, the vSphere ESXi, the hypervisor. That's just the heart of it, the core of it. There are all these features that are built around VMware that make it a really huge package. So there's a lot of offerings from VMware with the vSphere product line. Okay, so the suite is a comprehensive collection of products and features that together can provide almost any foreseeable or imaginable array of enterprise functionality. So here are some of the parts. Of course, the main part is the ESXi, which is the hypervisor. Then there is a product that is called vCenter Server, where it's used to manage your vSphere environments. Now, I have contemplated using vCenter Server in this course, but it really only makes sense to do something like that if one student was managing, say, 2 or 3 or more ESXi servers, then it would make sense to maybe do that via the vCenter server. But because each student has their own ESXi, and we can manage it through the web front end, it doesn't make sense to add another layer of complexity on there. But I'm saying in the real world, in larger environments, you're probably not going to log into each server with ESXi and the web front end like we are. That's only going to be appropriate for small environments where you only have one hypervisor that you are managing. Now, from a class perspective, we could have one vCenter and then manage everybody's server, but that kind of defeats the point of you learning how to use the technology. Okay, there's also an update manager. Okay, and I'm going to just list these and we'll look at their features later. There's a vSphere client, there's an orchestrator, there's a vSphere virtual symmetric multiprocessing, there's vMotion and storage vMotion, there's the distributed resource scheduler and the storage distributed resource scheduler. So, and there's all these other features here: storage input output, profile driven storage, high availability, fault tolerance, storage APIs, virtual SANs, replication, and then the flash read cache. So there are many versions of vSphere. This slide needs to be changed. It's actually 7.0 is the latest version, but you can go to VMware's website and you can see all the products that they offered. Now, in a typical environment, you would have multiple hypervisors, right? So each one of these ESXi hypervisor is its own server, right? That's a standalone machine, probably a server. It could be a desktop as well. And then each of these host machines will have different virtualization products running inside of their VMs. Okay. And then you're going to have a management network and then the storage area network for the SANs, which are these down here, which are shown with the two transport technologies commonly used for connecting to our SAN with either the iSCSI protocol or the NFS protocols. All right. So this is and then we have our vCenter server over here to manage everything. So that's kind of like our front end. All right. Now, what is vSphere? It's really a collection of products and tools that make the virtualization process possible. And when we're talking about vSphere, and when I say a large company, I'm really talking about companies that have offices and remote locations all across the globe. So, let's say, for example, we're talking about the Mercedes-Benz Corporation, right? That makes the vehicle line Mercedes-Benz. They would have their corporate office, which I believe is in Germany. They have another corporate office in the United States. They have offices in China and in South America. They have offices in uh, Europe, outside of Germany. So they're pretty global. And their IT team, if they wanted to, let's say that we're working in their corporate office in Germany, and our Mercedes-Benz office in, say, Argentina says, hey, can you spin up, can we create a new VM for this new point of sale system we're using, and they'll give us the specifications. And we could initiate that from Germany and have it show up in their environment for them to use. And we could set it with all the bells and whistles of high availability, fault tolerance, failover. We could use our solid state drives for the network storage. So it really is a global product. And when we start looking at adding in all of these components, right? If we go back a couple slides here, and if we look at all of these systems that we have added on top of it, and of course, all of these are add-ons, right? They're optional, purchasable plugins that we can add to our environment. If we get into a large environment, like say Mercedes-Benz, that's global, we're talking easily over $1 million price tag to pull this off. So it scales up very, very large. And then of course the price tag is just as large. Okay. So we can virtualize different things, right? We talked about this when we introduced the concept of virtualization a few weeks ago, when we mentioned why we would want to virtualize. We can virtualize computing devices, which is really what we're doing. We can virtualize and have products to help us manage our virtualization. And then we can have the hypervisor, and then we can have storage. Okay. So there's a lot of potential for that. Now, I found this, I was reading the book on VMware's vSphere, and they mentioned the reasons to virtualize, and they say an ASOM, or a simple orange monster. So you see the picture there. I found a good picture that shows an orange monster of sorts. I don't know what that would symbolize, if it's a buffalo or a demon spirit or some cartoon character, some anime. I don't know what that is, but a simple orange monster. So keep that phrase in mind. And the ASOM stands for, the acronyms, the abbreviation ASOM is an acronym for availability, scalability, optimization, and management. So if somebody were to ask you, let's say you get hired on at a company and they're relatively new in their IT products, and they ask you, what do you know about virtualization? Why would we virtualize? Just remember a simple orange monster. with the availability, scalability, and optimization and management. So let's unpack each one of those as we go. Now, one of the metrics by which all IT people are either formally or informally evaluated, right? So like your annual performance review, when your manager calls you in and says, let's talk about how you've the work you've been doing here for the last year or whatever the evaluation period is. One of the first things they will probably bring up is how reliable, how available were your systems. So, I mean, imagine if you were to go to Canvas and every third time you click on Canvas, you get a notice says, sorry, this service is unavailable, check back in an hour. Or worse than that, even getting a message, what if it just doesn't respond and you get the page times out? And then you get your browser error that says there may be a problem. Do you want to look at it and troubleshoot it, right? So downtime is really the standard by which a server technician in particular is evaluated. So if there was a product that could minimize or maybe even eliminate any possibility of downtime, your server admin ears would perk up and say, what did I just heard something that I really want to pursue, right? I want to have a network and a server infrastructure that is always available, because that's what users expect, right? The end users, they're not IT professionals. They could care less if it's Server 2019 or CentOS, or if you're, virtualize it. They just want, when I click on my desktop icon, it accesses whatever the system is and wherever it is and how it works. I don't care, as long as I can get in there and do what I have to do as part of their job description. So if we can prevent downtime, that's always something we want to look at. So the A in a simple orange monster is referring to availability, which is what we want. We want as much availability as possible. So one of the other areas besides unscheduled downtime, right, where stuff just happens, right, things go down for reasons beyond our control. Maybe there's a power failure, maybe there's a kernel panic or some sort of blue screen from something that happened on the machine itself. But sometimes we have scheduled downtimes, right, where we know we need to apply an update, and we normally look at our calendar, our daily planner, and say, well, it looks like between 3 a.m. and 7 a.m. there's very little activity on the network. Let's come in the early morning and apply these updates. So we would do that. Now, if we're global, so 3 a.m. in Germany is, daylight or the middle of the day in Asia, and it could be in the afternoon in the South America or whatever the time zone differences are. And if we're providing that, we're looking at downtime, right, just to install an update. Well, with virtualization, we can install updates anytime, because we can fail over, we can move these machines around without any downtime. Okay, so the availability just keeps getting better and better and better. We can deal with hardware failures much more programmatically, where we can just kind of roll with the changes. If something fails, we're prepared, right? We have a redundancy where there's another VM just like the one we're using that will just automatically pick up the workload from the one that just failed. Okay. We can do backups and restores, and then we can test our backups all in real time. So that's what availability is referring to, right? Any questions on the A in ASOM?
I don't think right now, maybe.
Say that again.
Not right now, maybe.
Okay. Anybody else? Don't be shy. All right. Someone said nope in the chat. That's fine. You can always put your comments in there as well. All right. So that's availability. Now, some of the levels of our availability are going to refer us to things that are beyond our control, right? I can virtualize our entire environment, and I can make sure that that server that's acting as our router is always available 100% of the time. But what if the network that our server connects to for our internet service provider, what if they go down? Well, that still is going to be recorded or be annotated as an availability problem under my watch. So some of these areas we have to look at, how do we scale that up or make that available with outside vendors, and where we can look at that. And you'll see this term throughout the basically all the CompTIA certifications, whether it's the A+, the Network Plus, the Server Plus, or the Security Plus. They're going to refer to these SLAs, or service level agreements. And these SLAs basically say, this is what, say we're using Spectrum Business for our internet connectivity, it will tell us what their uptime guarantee is. So they may say, we guarantee our availability of 99.9999%, right? Which is a total of 5 nines, which is kind of the gold standard in IT, is if you can get 99.999%, that's less than a minute of downtime per month. So a total of 12 minutes a year. So it's very, very low downtime. So if we can get an SLA, and some of these providers, guess what they're using in their environment? They're using the same technology that we would use in our environments to help them guarantee their uptime and their high availability, because reputation in IT is a huge thing. So the availability is part of that. Okay, so the next section, the A, which is the A, and then simple, is scalability. Now, one of the things that we want to make sure in our environment is that normally we're concerned with scaling up, right? Getting bigger as the company grows, or as the services begin to take off. How can we grow our infrastructure or scale up our server environment to fit what the business is doing? Now, there are times where it's like an accordion, right? Where it'll go out and then it'll collapse back in, right? There are certain seasons where we may need to scale up, and then when that season's over, we may scale down. So a really good example of this is during the registration period at Mount SAC. So during the registration period, their portal and their system for registering classes is under a huge amount of load, right? There's over 50,000 students trying to log in and get access to their class schedule so they can schedule and register for courses. So during that time, and say 2 months later, like right now, when there's not a lot of activity, I mean, there's not a lot of registration going on right now. They don't need to have built out a huge environment. Now, I'm not aware of how Mount Sacs IT department does this, if they kind of grow it up for those seasons and take it back down a little bit, or if they just say, well, we just need one big honking system to deal with this, and then we'll be ready for the next time. But scaling up is where we grow and add servers to our environment. Now, with physical machinery, this could take days or weeks or even months, right? Go to Dell.com and order one of their servers and set it up with all the bells and whistles that you'd want, and hit purchase, and you may get an email that says, we'll have an engineer build this and test it, and then with shipping, you may not receive it until the middle of April, right? It could be 2 or 3 weeks from now. So, and the answer to most IT questions, when we say, well, when do you need this done? Most of the time, the answer is, I needed it done yesterday, right? Not tomorrow, not 3 weeks from now, not next month. I need it right now, or, if it was up yesterday, would have been better. So in our virtual environment, and we're going to see, today will be a little bit of that. Now, up until this point in the labs, we've been building, right? We've been in construction mode, where we've been constructing and laying the foundation and putting the bricks and put up the frames and the trusses. And so now we have our structure that we can now start taking off from and say, let's start putting some routers in here. Let's do a domain server. Let's do some file and print sharing. Let's do some high availability with iSCSI. Let's do some web services and all the different things that we've discussed. Now we're going to start doing that. And instead of taking an hour or so to build a virtual machine, we can clone it and within an hour have it functioning exactly the way we envision it. Now, as we mentioned in the week 1, licensing always has to be considered, right? We always want to take into account what are some of the licensing restrictions, because we are going to be constrained to what we can or cannot do based on licensing. We can't just fire up 500 virtual machines with server 2019 and use the same license for all of them. That's not going to work. Okay. Now, another feature that we can use in scalability is this concept of building a template. Now, we've done this to a degree with the 3 VMs we've already built, in the fact that I've had you name them WinServer-parent, CentOS 8-parent, Win10-parent, right? Those are going to be our parent virtual machines for our clones that are going to be our template. So everything's going to be based on those VMs. So when we start a new VM, it will start up, and all we have to do is go through a couple of steps to initiate it, right? With the out-of-the-box experience, put in a username, a password, select the time zone, and basically it's just next, 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 and away we go. So when we, in today's lab, I'm going to show you how to prepare those for that. And that will allow us to take our parents and clone them up really quickly. So that's like our template where we can make clones of the gold stamp. So this is our initial, this would be like our parent VMs would be the gold stamp. And then our clones will be, the ones we're going to use after the fact. Okay. Now, one thing in lab, and I'll explain this in more detail as we get there, is we want to be sure that we don't, once we assign our parents as the template, we do not want to use them for anything else. All they're used for then from that point on is to clone other things from. They really don't have a purpose on our network other than to spawn off all these other virtual machines. So we want to, actually, we're going to remove them from our management console so we don't even see them anymore. Now their files are still available, and those are what we need to clone them. But as far as them actually being a, let me click here and start it, that's not going to be possible. Okay, so we're going to move them away so they don't get accidentally used. Okay, so that's part of scalability. Now, another thing that we will look at is some applications play well with other applications and others do not. So for example, next week when we do a domain controller, DNS and DHCP and Active Directory, they live very, very comfortably in the same neighborhood. Whereas other systems like failover clustering or clustering in a Windows environment, you don't want a domain controller to be clustered. I mean, you want it to be part of a cluster, but the actual server that your Active Directory is running on and the server that your failover clustering is running on should not be the same server. Now, because they don't play well together, and and it's just kind of some of these best practices that we'll find and we'll unwrap as we go, and we'll see which systems work really well together and which ones don't. So we always want to keep that in mind. I mean, if you have one server in your environment and you just keep putting more and more and more services on it, even though they're low impact services, right? Say they're not getting, say you put a web server on your server hardware, and it's also your domain controller and your authentication server. Even though your website doesn't get a lot of traffic, that's a lot of different functions that can start colliding and cause you some problems as far as performance. So separating them sometimes is a better use of our resources. Now, scalability also allows us to add more hardware. Now, normally when we think of scalability on our desktop machines, the first thing that comes to mind normally is our hard drive subsystem. So adding storage is something that we're used to doing, or we're familiar with doing with our hardware, especially with our RAID arrays, right? Our redundant array of independent disks. So adding new hard drives to a RAID array normally is hot swappable, right? And normally on the front of our system, there's, buttons and tabs that allow us to remove and add hard drives with the machine running. Well, with certain servers, and with our scalability and our availability that came before it, we can now add hardware, CPUs, cores, memory to our server environment without having any downtime. So the scalability builds on the principles of the availability. All right. And then we can add network attached storage, which we're going to do a lab where we'll add into our environment iSCSI and NFS targets and sources so that we can add those into our environment for additional storage of our virtual machines. All right. So with the scalability, we can scale network storage to monitor the network-based storage and scale accordingly. So one thing, and you guys have probably seen this in your own computing environments, is when you build your computer or you build your home network, you may look at it and say, okay, I have a 1 terabyte SSD, say it's an M.2 NVM drive, and then attached to that, I have a 6 terabyte external hard drive, and that should be more than enough space for what I want to do. Well, 6 months down the road, after you've been, doing some video projects and, a lot of virtualization, suddenly that 6 terabytes of hard drive space and that 1 terabyte of internal space may not be adequate, right? And now the external, that's relatively easy to replace, right? You just buy a bigger one and either add it to the additional or just transfer what's on the old one and put it on the new one, plug it in, everybody's happy. But what about that 1 terabyte internal drive? Swapping those out takes a little bit more than just saying, well, let me take this one out, put the new one in, copy it over, and then we're good to go, right? If it has your operating system and all your program files, there may be a couple of steps in addition to just taking it out and adding it. So knowing that, it's going to require some downtime, right? To work with your internal hard drive on your own machine, like the computer you're using right now to connect all this, that would require a little bit of planning, and there would be availability would be hit, and then to scale would be difficult. So with our networks and our virtual environments, this scalability becomes much more dynamic, in that we can kind of go with the flow a little bit, add more storage, remove more storage as necessary. Okay, so that's a simple, is the availability, scalability, and then the orange is the optimization. Now, to optimize our environment, really, if we do the availability and the scalability properly, the downtime and the repair aspect, hey, this is down, can you fix it calls, those kind of are going to subside. They're going to become less and less, but we still would have that infamous IT call of my system's slower. It doesn't seem to be as fast as it used to be, So this is where we can optimize our environment. And this is where we can identify bottlenecks. We can look at, well, how is our storage provisioned, right? What type of disks are we using? How fast are the spindles? Are they 10K? Are they 15K? Are they solid state, which would be the fastest? And if they're part of our storage area network, what protocols am I using, with iSCSI being the preferred one? So the higher the performance of our environment, the higher the performance of the storage, right? They should fit. So we're not going to put a really slow, like a 5,400 RPM hard drive in a server that has a ton of input output per second, or IOPS, for the drive, right? Let's say it's a high-end database server with a ton of memory and a lot of CPU, and then we put the slowest hard drive we can find in there. Well, guess what's going to slow that system down? That's like, having Usain Bolt, right? The Jamaican sprinter, the 100-meter and 200-meter Olympic champion from Jamaica. We want him to be the runner, right? We know he's fast, but if we said, well, we need you to put on this parachute and that's going to run, and then we go, well, why did he come in third place or fourth place, or why didn't he get a medal this time? Well, because we didn't match him up right with the right suit, right? The right uniform. So we have to optimize our networks the same way. And once we kind of get a big picture understanding of all of the components here, it's going to will fit the pieces better, right? They'll work much faster. Like, have any of you ever tried to solve a Rubik's cube? And um, go on YouTube and look at, Rubik's cube world record or whatever, and there are guys that could solve it almost as fast as you can see the cube turning. They'll have it solved. And then how many of you have solved a Rubik's cube by taking it apart, right? I remember um, the Rubik's cube's been around a long time. I remember when I'd ride the bus to school, and when the Rubik's cube first came out in the 80s, and there's this one guy who said, I can never do it, but I can, and he would turn it and pop all the pieces off and then stick them back together. And it takes a lot longer to build it that way, right? If you know how they fit together, it's much faster than breaking it down and just kind of manually reconstructing it. So once we see how all these pieces fit together, we'll be that expert Rubik's Cube solver. All right, so that's optimization. Now, one of the things that we can do in our prioritization is our network. So we can also virtualize and give priority within within vSphere, our priority of our data traffic. So if we have on our virtual environment voice over IP, we can prioritize that traffic over, say, someone downloading a file from the internet or from a file share. So the ability to tag with the quality of service for various protocols or various services, we can say this always gets priority. It's like when you're in traffic, the people that can get in the carpool lane, they seem to have a priority over everybody else, right? They're optimized to go at, without as much traffic. So the same thing, we can do the exact same principle with our network traffic. Now we can also under or over provision our VMs. So we may think, well, this server is going to do some file shares. It doesn't need a lot of memory, doesn't need a lot of CPU. So we'll kind of check the boxes and say, give it, a little bit of memory, a little bit of CPU, a little bit of this and that. And then when we put it into the environment, right, after we do all of our planning, we may look at it and then optimize it and say, you know what, this server needs more, right? We didn't give it enough. So we can just say, okay, give it more memory, give it more CPU, give it more network traffic. And we can just build these and optimize these with just a click away, right? So it's all software defined, where we can just click and say, add more, give it more, give it less, give it less. So maybe on a Tuesday, our web server is not getting hardly any traffic, but our database server is getting a ton of work done on it. So on Tuesdays, we may want to say, okay, take a little bit of memory and CPU from the web server and slide it over to the database server, so it has a little bit more capabilities. And then on Wednesdays, do the opposite, right? That's when our web server gets a lot of traffic, but our database server is hardly used. So we can define that with the aptly named V orchestra. We can orchestrate that and say, okay, this is how we're going to play this out. Okay, so optimization gives us the ability to do that. And then finally, the last of the 4 ASOM, a simple orange monster, is the management. So with management, we may have some legacy systems, right? We talked about legacy servers and systems previously, and the ability to find old hardware can be difficult. I had a student a few years back, and he said that he started his own computer repair business while he was a CNET student. You know, he got in the program, and he said, well, you know, all these people are always asking me to work on their computer. I'm gonna see if I can just, you know, make it into a little business. Well, over the 2 years he was in the program, um, at the end, he had built up probably a client list of, you know, 30, 40 people. So, and then one day he came to me and said, hey, I have a customer that has these older machines and they want to replace them, but I bought new hardware for it, but it won't run. That it's too new for their legacy system. So the software they were running, it was in a like a warehouse, uh, wouldn't run on the newer processors and memory and operating systems. So he said, and I can't go buy a new Pentium motherboard to replace the one in their old Pentium machine. I mean, I just can't find them. So I said, well, can you virtualize it? Can you virtualize the system and give it, you know, a 32-bit virtual environment, and see if it will run in there? And sure enough, it worked perfect in a virtual environment. So I say, you just saved me and my customer a ton of money, because I can just put one of the machines I bought for a replacement, I'll just make that into a virtual server, and then we'll virtualize these different things and have them connect to it. And they were able to you know, keep using their older system, you know, because like we said in a previous lecture, you don't replace technology just because there's new technology. If it's making money, if it's working, there's no reason to replace it, right? And that's exactly what this company wanted to do. They said, no, you know, we're not buying new hardware or new software to fit your new hardware, just because that's, you know, and we were able to figure out a solution for that. So hardware compatibility lists, this HCL, for older systems can be difficult to find. And then the other part of virtualization, it allows us to manage hundreds of servers from one dashboard. So from one server admin can kind of have the overview or the purview of hundreds of servers that may be hosting thousands of virtual machines. And in vSphere, that's known as the vCenter server. So that's the name of the tool that we would use there. And then another management factor is the cost of the power and the cooling. So we may identify low usage or no usage virtual machines and move them to a server that is getting a lot of activity. We may move the low one over there because it's not going to have a lot of impact. And then we can power down, you know, the server that's not being used. You know, it's like, have you ever been to somebody's house and maybe they have a large floor plan, but there's only a couple people living there, so they close off part of it, right? They close the air conditioning and the heating ducts. They seal off the doorways, so they're not spending money or wasting heating and cooling or power for an area of the house they're not even using. You know, same concept. So we can do that with our virtual machines. Okay, so So that's the optimization part of it and the management. Okay. The other thing with the management is we can make sure that we're in regulatory compliance. So there are certain federal regulations like the Sarbanes-Oxley Act, the SOX, and then the healthcare, whatever, IPAA, I always forget what that stands for, but HIPAA, right? We probably heard those terms, especially during the pandemic. If you've used telemedicine, where you Zoom with your primary physician, and he wants to share your screen, and he has to tell you, well, there's some information, some of your information will be on the screen. Is it okay if I share it with you? He's getting make sure he's compliant with HIPAA. Those things can be difficult to identify in a non-virtualized environment. If we have one area that we can monitor all of our traffic, we can ensure that only certain types of data is allowed in and out of our system. So that's one way that we can take care of that. So as far as compliance, we can handle that from management as well. All right. So that's a good place for us to stop for our first break, is the simple orange monster. So if you go back to our picture here, right, here's our little orange monster, a simple orange monster. And someone tell me, what's the A stand for? Shout it out.
Availability.
Availability, good. What does the S stand for?
Scalability.
Scalability. And then the O?
Optimization.
Optimization, very good. And then someone other than Frankie, what's the M stand for?
Management.
Management, good. So when you think of why do we virtualize, those are the four biggest reasons: is the availability, the scalability, the optimization, and then the management. All right. Any questions on that material? No? Okay. Well, let's take a break here. We'll go about 7 minutes, and let's come back at 9 a.m. and then we'll continue going here. All right. So I'm gonna pause the recording. All right. So let me get back into my share here. Share screen. So get to the screen where you're at. All right, so now what we're going to do is just kind of take a little walk through some of these services available in vSphere. Now, again, these are add-ons. These are additional packages that we can purchase along with the ESXi hypervisor. So these are not free. They can add up very, very quickly to the overall price tag of virtualization. So the first one is this service called HA, or high availability. And this just says that should a virtual machine fail, the VM is restarted on another hypervisor. So the VM will be relocated to another server and then started over there. Now, this does have some drawbacks in that the hardware, if this is on a physical machine, the hardware has to be identical, right? If you've ever taken the hard drive out of one machine and put it into another machine and turned it on and booted from that hard drive, it may or may not work properly or it may have to go through a bunch of updates to reconfigure the hardware on that machine. You know, we kind of saw this a little bit last week when we moved or tried to move from VMware Workstation to ESXi. First, we had to get the hardware compatibility on the same level, right? To VMware ESXi 6.5 when we went into the management to the, and then we also found out that the network card that it installs in VMware Workstation is different than the network card that server uses, the ESXi. So we had to delete the network card and then we were able to move it. So the hardware can always be a problem area with the just moving something across the thing. Another thing that we can use with our virtual environments, and we don't use this in our labs. And the reason for it is these snapshots can actually add a layer of complexity to our environment, especially when we start looking at the hard disk files and using them for cloning, or when we get into Hyper-V, we'll call them differencing disks. The snapshots can cause inconsistencies there. But in a regular environment, that's just in our learning environment, our lab environment, where they're not perfect. But in a regular environment, we would probably want to use snapshots before we do any major changes to our virtual machines. So if we have a server and we know Tuesday is Patch Tuesday is the first Tuesday of the month when Microsoft releases updates, we may want to build into our systems every Monday morning or Monday night, early Tuesday morning, let's have it take a snapshot. That way, if the updates are downloaded and installed and they cause a problem, we can just roll back or revert to where we were, Tuesday at 1 a.m. in the morning. So snapshots are a good idea there. But in our environment, we're not going to use snapshots, okay? But just know that it's out there. All right. So with our ESXi server, the physical resources that we're using are really only found in two files. The information is found in the configuration file, which is the XFG, or hold on, I'll show you this in the lab, the VMX file. So for our servers, our virtual machines, the VMX is the configuration file. Then the VMDK is the hard disk file. So those two files are the ones we're going to have to use when we build our clones. So the physical resources are virtualized and they're found in those files. Now, again, we mentioned this a couple weeks ago, and we looked at it again last week when we looked at the rings, right? The ring 0, ring 1, and the history of VMware. The type 1 and type 2 hypervisor, the type 1 runs directly on bare metal, type 2 runs on top of an operating system. So last week we saw both of them, right? Type 1 is our ESXi server. That is a type 1 hypervisor. Type 2 was the VMware virtual, the workstation that ran on top of, it was an application that we downloaded from a server and then ran the installer and then just, clicked our way through it. And it ran as another application inside of Windows 10. So we had the hardware layer, then we had the operating system layer, and then the application layer where we installed the workstation, then the VM Windows 10 inside of it. So we had a couple layers going there. And we know that it's an application because we were able to uninstall it at the end, right? We went in the control panel, add and remove programs and got it out of there. Okay. So that's the type 1 and type 2. So here's type 1 right on the hardware, type 2 right on top of the operating system. Now, and ESXi is type 1 and workstations type 2. Now, the core or the main component of vSphere is the ESXi hypervisor. And that's the system that we've been interacting with, right? I've had you look at various parts of ESXi to kind of get a lay of the land, if you will, of what is included in there and how do I find information. So like last week, I actually had you turn on the SSH so for remote management, because what I had to do is I had to go in and update the license, the trial license. I had to change the configuration file in ESXi so that our license didn't expire before the midterm. Because I was looking at mine and I was like, it says it expires in 41 days. And then I looked at my calendar and I was like, you know, the lab midterm is 46 days from now. This server isn't going to make it. So there's a script you can run through SSH. So I was able to use an SSH program called Putty, and I was able to log into your servers and then run the configuration script to update and it's a free license. It's not like, you know, I'm hacking a license for you. It's a 60-day trial. And because I installed all those servers in August, which is normally we don't do that until week 1, and I did it, you know, a couple of weeks before I was going to miss my deadline for the licensing for the midterm. So I had to log in with SSH. So you were able to, you know, configure ESXi using the tool sets there. Now, ESXi runs a Linux-based kernel known as the VM kernel. So if you've seen any of the, not error message, but the confirmation messages, sometimes you'll see something in there that looks very much like Linux commands, because that's what they are. So it's the VM kernel that manages the virtual machine's access to the underlying physical hardware by providing the CPU scheduling, the memory management, the virtual switch data processing, and so forth. So just like if you were to run, say, Ubuntu or CentOS or Red Hat or Fedora or, you know, Tiny Core Linux, any version of Linux, any distribution, you can install virtualization in it, and the kernel does most of that for us. Okay, so VM kernel is the kernel of the Linux operating system that ESXi uses. Okay, so here's the hardware, there's the hypervisor with the VM kernel, and there's our guest machines or our virtual machines above it. Now, ESXi can support up to 4,000 virtual CPUs, 320 logical CPUs, 32 physical or virtual CPUs per core, and up to 4 terabytes of RAM. So this Linux kernel here, right, the kernel itself is not a typical kernel of Linux or say Windows with the Windows kernel that can only support smaller amounts of systems, right? So this is an optimized kernel. It's been coded in a way that will allow a large amount of hardware, right? So 4 terabytes of RAM per host, that's a lot of memory, right? Our servers only have 32 gigabytes of RAM, which for a desktop machine, right now, that's about average, right? Many of you probably have 32 gigs of RAM in your machines. On my little computer on my desk, I have 32 gigs of RAM. So that's typical. But 4 terabytes, that's a lot more memory than 32 gigs, right? That's a order of magnitude of 1,000 times bigger, a terabyte to a gigabyte. All right. Now, so that's the hypervisor. The next component that typically in a larger environment will add into the system is the vCenter server. And this is our management aspect. So with vCenter, you can easily take an existing virtual machine and create a clone of it just by clicking it. Now, we're not going to be able to do that because we don't have vCenter set up in our environment, because it would be way too much overkill for what we're actually doing in our environment. So for us to do it, we're going to actually have to work with the VMX and the VMDK files to build our children from our parent, to spawn them off or clone them off. So, but vCenter provides a framework for the hosts and the virtual machines that reside in the host. And vCenter uses a backend database, either Microsoft SQL or Oracle, that stores all the data about the host. And then that database is stored on a central or a storage network where the storage can be optimized. Okay. Now, you can run vCenter. It can be downloaded and installed on a Windows server, or you can do it as a virtual appliance. Now, if you do the virtual appliance route, it runs a SUSE Linux-based operating system. So if you've done anything with Linux, you know there's various distributions. Debian, Red Hat, SUSE are probably the main three, and then everybody else is based on them. But the vCenter Linux appliance is actually running SUSE. Okay, now you have to have vCenter as the foundation for many of the other advanced features that we're going to look at down the road, such as vMotion, the DRS, high availability, and fault tolerance. Okay, so there's vCenter. Now the VUM, which is the vCenter Update Manager, this is an add-on package for the vCenter server that helps us update our ESXi hosts and any of the VMs within it. So it's similar to the Microsoft Server Update Service, the WSUS, in that it will go out and find the updates for us. Now, all of this has to be licensed, right? So if we want updates from VMware, we have to have a current license on our ESXi to download those updates. And a trial license doesn't work for that. So we really don't get into the updating of our ESXi servers, but in a regular environment, you would make sure that's part of your management and optimization of your environment. So VUM can provide the following functionality. It will like scan your systems and find out which one of those host machines, either the ESXi hypervisor or the virtual machines within the hypervisor, are not updated. So it can look at them and say, hey, this does not have the proper updates. And then we can apply various rules that we set up and tell it to do the update process for us. So it's just an kind of an automation of our updates within not only the Windows environment, but Linux and VMware as well. So the vSphere Update Manager. Now, VUM provides the following functionality. It automates the installation of patches, and it fully integrates with other vSphere features like the Distributed Resource Scheduler. And this will work with both the Windows-based install and the virtual appliance in the vCenter server. Okay. There is, well, I should say, there used to be a vSphere client that was used to manage the vSphere ESXi. And the client, I don't think I have a picture of it here, was a standalone program that you would download from your ESXi server onto your Windows machine, and then you could run it locally. And this is this was a victim of Adobe's Flash. Remember the Adobe Flash was a back-end technology used for a lot of web servers, and it allowed an application to connect to a web server and kind of gave it some polish to it. Well, Adobe Flash was very, very insecure in that it had a lot of vulnerabilities, and Adobe stopped supporting it. And then they finally said, this is the drop dead date, was a few years ago or a couple years ago. And this vSphere client was built on Flash. So when they switched from vSphere 6 to 6.5, they stopped the vSphere client. Now, there's some workarounds where you can get the client from an older version of ESXi and do some updates, some with the .NET framework for the Visual C++ or C# and the .NET framework, and make it work. But it's totally unsupported anymore because it's unsecure. So that's why we're using the kind of the industry standard is to use the web interface like we're doing. And we can do everything on the web that you would do in the vSphere client. But the client just gave you a one-stop shop here. Okay. And then the vCenter Orchestrator is a workflow automation engine that is automatically installed when you install vCenter server. So the orchestrator allows administrators to build automated workflows for a wide variety of tasks. So for example, I may want to, on a regular basis, push updates using VUM to all of my, ESXi 6.5 or below servers. And I may want to do that, say, every Monday afternoon when there's a lull in the usage time. So I could schedule that, and then the orchestrator will go through and just automatically run those. So it's kind of like the Windows task scheduler, right? Which we can set up in Windows to do certain things at certain times on steroids. So this is just a big system that allows you to orchestrate the workflows within your environment. So it's directly tied into the vCenter server. All right. We can also, there's a product called the vSphere Virtual Symmetric Multiprocessing. And this allows virtual infrastructure administrators, which allows to build virtual machines with multiple virtual processors. Now, CPUs can be run in VMs configured with multiple virtual CPUs. So when we build our VMs in our setup, right, which for the most part, we've just accepted the default hardware configuration. I did have you change the memory in Windows 10 last week, but generally we're giving them 2 gigs of RAM or 4 gigs of RAM and 1 virtual processor and 1 core. That's been the standard so far. Although the CentOS was 1 core, 1 processor, WinServer parent was 2. So it had 2 by default. But this allows us to have up to those 32 cores per VM. So this allows us to get bigger and go above that. Okay, so here's the virtual symmetric multiprocessing with Linux has 2, and then this one has 4, whereas these ones are only using a single processor. All right. And by the way, I mean, our host machine has to have multiple cores and multiple processors to virtualize that as well. All right. The next product or application that we're going to talk about is the vMotion. And vMotion gives us the ability to perform a live migration of a running virtual machine. So those two terms, live migration and running virtual machine, live and running, tells you that a system can be moved with vMotion without experiencing any downtime or loss of network connectivity. Now you have to have vCenter server to use vMotion. It's one of those integrated systems. So we can move our VMs with vMotion. Now, the vMotion moves the execution of a VM, relocating the CPU and memory footprint between physical servers, but it leaves the storage untouched. So whenever you see any of these systems that require centralized storage, that is almost always going to be referring to what's known as a SAN, a storage area network, which we're going to build a couple SAN devices into our environment in a couple of weeks, a few weeks. It's actually in the second half of the class, but it will show us how we can move our virtual machines, and the data, the disk file and the configuration file stays in the same location because it's in the SAN, but the CPU and memory on one server will be transferred to another server. Okay, then we can also do the same thing with our storage. So we can have high availability or availability for our storage, which means we need redundant storage containers. So storage vMotion builds on the idea and principles of vMotion by providing the ability to move the VM storage while the VM is still running. So with vMotion, the storage stays in one location. With storage vMotion, the storage moves to a new location as well. Now, normally, our vSphere environment is going to be built on the concept of shared storage. And I'm going to talk more about storage in the upcoming lectures. But for now, it's just our hard drive location. And instead of it being physically located in the same chassis or hardware components of our server itself, it will be a separate server and dedicated to some of these protocols, fiber channel, iSCSI, or the network file system with NFS. Okay, so that's storage vMotion. Now, storage vMotion is manual, meaning that we have to initiate it. What if it could happen automatically? And that's where the DRS comes in. So the distributed resource scheduler automates the movement of the storage vMotion. So it's the automated. So as I said, each one of these systems is adding on top of the other. And as they add up, so does the price tag. So these are really powerful systems, but they are kind of out of reach for the typical business user because of the cost. But the larger environments, like I said, Mercedes or global industries, this is music to their ears because they want to be able to make sure nothing goes down ever. That's always available, and they don't care what it costs. And VMware is happy to provide them with that service. All right. Now, the DRS can also work with clustering, and we're going to just we'll have a lecture in the lab on clustering in a Windows in Hyper-V in probably about 6 weeks from now, where we'll get to that. And the ESXi cluster is an aggregation of the CPU power and memory of multiple hosts that are part of a cluster. Now you need 2 or more servers to make a cluster. And once they're assigned, all of the processing power and memory is an aggregate, or it's added together for the VMs in that cluster to use. So I may have one server with, say, 1 terabyte of RAM, another server with 2 terabytes of RAM. If I cluster them, all of the VMs in that cluster will see 3 terabytes of RAM, even though they're on 2 separate machines. So it just aggregates the CPU and the memory processing there. But you cannot, I could not assign, if I'm on that 1 terabyte ESXi, that's where this VM is, I could not assign it more than 1 terabyte of RAM because it cannot be greater than the single ESXi host. Now the total availability to the cluster would be 3 terabytes, but on that particular machine, you can't go greater than the machine itself or the host machine itself. Okay, so that's what this paragraph here is saying. Now we can also use DRS so that at startup, it attempts to place each VM on the host that is best suited to run that VM at that time. So remember, we said that sometimes these workloads are dynamic and that they change, right? So for example, this morning, our web server may not be getting a lot of traffic, but tomorrow it may have different traffic needs. So DRS is going to manage that and distribute the VM. It may move it from one system to another and the storage that goes with it, not just the processor, and take advantage of maybe some of these clusters that are larger, have larger resource pools. So it will help it there. So while a VM is running, DRS seeks to provide that VM with the required hardware while minimizing the amount of contention for those resources in an effort to maintain balanced utilization levels. So it's going to manage that for us. So very, very powerful stuff here. Now, the first part is sometimes referred to as intelligent placement. It does it on the fly without any downtime. And this makes the distributed resource scheduler extremely powerful because it allows clusters of ESXi hosts to dynamically rebalance their resources. So it allows them to just kind of make sure this machine's not way up and this one way down. Let's kind of level that off so everything is optimized. Okay, there's also, just like there's vMotion and storage vMotion, there's storage DRS, which will balance our storage clusters. And then there's the input output control and network control where for storage and the network. And this will also ensure that the priority VMs have the resources they need. So this is how we make sure that there's no bottlenecks with our controller cards, whether for the storage, the hard drive controllers, or the network controllers. Okay. Now, network input output control provides an administrator with granular controls over how VMs use network bandwidth provided by the physical network cards. So and most servers have at least 4 network cards in them. Some of them have much, much more than that. And what you can do is you can take all the network cards and do like a cluster on the networking where you just add 1 gigabyte, 1 gigabyte, 1 gigabyte, 1 gigabyte. Boom, now it sees one connector or one device that has 4 gigabytes of aggregated bandwidth. So and then we can use the storage, the network input output control will manage that for us. and distributed accordingly. We can also use profile-driven storage. So we can allow the virtual machine storage profiles that ensure the VMs are reside on storage as able to provide the necessary levels of capacity, performance, availability, and redundancy. So some systems have different hard drive requirements, right? If we're doing a lot of file input output, we need fast transaction speeds. If we're dealing with larger files, we need high capacity, right? That's more important than the speed. Database needs speed. Large files need large capacities. So both of these will be looked at or is part of this profile-driven storage feature. Now, these are either provided by the storage array itself and or by the vSphere administrator. So VM storage profiles define the storage requirements for a VM and the virtual hard drives that it uses. All right. Now, the high availability. This is one of those concepts that some people will say, well, if you want high availability, don't put all of your eggs in a virtual basket, right? So, because if your virtual environment fails, everything fails, right? All of your servers are down. It's kind of like when we talk about the cloud is awesome and it has tons of availability, but what if the power goes out? Well, then you have nothing. Well, in certain environments, then you start talking about generators and battery backups and, offline power. But in general, I mean, there's just only so much you can do. So this high availability concern is addressed with the ability to cluster your ESXi hosts. So this provides an automated process where it'll automatically restart the VMs that we're running on one ESXi host and move them to another host. So this gives us the availability. Now, there is, while these hosts, so if this server goes down, these VMs will be moved to another host that's running. There is a small amount of downtime. While these are in transit, moving across the network, there will be some downtime, okay? So high availability, unlike the distributed resource scheduler, does not use vMotion. Because remember, vMotion is planned. We move these, while high availability is not planned. Though it'd be nice, wouldn't it be nice for you to plan when you have a failure? It'd be nice to say, well, this failure that's supposed to happen tomorrow night, that's not a good time for me because I have an early morning class the next morning. Let's move that unplanned downtime. Let's schedule it. I mean, it'd be nice to be able to do that. But this high availability handles it even with if there is an emergency situation. Whereas vMotion and DRS is like, we know about that. We're the ones initiating that. This is just, the luck of the draw initiating these. Okay. Now with HA, it's important to understand that there will be a slight interruption. So if the physical host fails, high availability restarts the VM, and while the VM is restarting, the application and services provided by the VM are unavailable. So while it's transferred and then starting up, there's downtime. Okay, there's another layer to this high availability known as fault tolerance. So fault tolerance goes further than high availability and eliminates any downtime. So now fault tolerance uses a technology known as the vLockstep that really is like the with our file system of where it keeps a record, right? There's a cache in our file system of our activities, and then that gets written out when the disk isn't in use. This vlockstep is similar to that. So it records and then replays the functionality of a host and mirrors that information to another physical host. So everything that happens on the primary or protected VM is kept in lockstep with the secondary or mirrored. And then if the primary is unavailable, the secondary comes right into play. So this is a kind of the concept of fault tolerance clustering. So like you've probably heard the term failover clustering. That's exactly what happens here is the node 1's running and node 2 is running too at the same time. And it's keeping all the data updated between the two nodes. And then if node 1 goes down, node 2 is already running and has all the latest transactions. So it's an exact copy of what happened there. And there's no downtime. There's literally instantaneously it switches over. Okay, so unlike our high availability where there is downtime during the failover, with fault tolerance there is no downtime. So these VMs, these copies have already been over here, and all the data, whatever data was in this server, gets updated to this server, and then when this one goes offline, this one immediately comes online. So it'll prevent any kind of downtime. But, right, and that's a big but there's always these costs to that. To ensure this kind of uptime and this type of availability, it starts adding up into the stratosphere of costs. Okay, now one of the critical aspects of our design of any network is backups, right? And how do we back up our system? Now, knowing, even if we knew we had fault tolerance, do you think we would still want to back up these VMs? So let's say this is my Active Directory domain controller, which is now this one here, right, when it fails over. Would I want a backup of this if I have a mirror of it here? Do I need a backup? Anybody? Someone answer that question in the chat. Would I want to back up? Yeah. Okay, Ellen, you said yes. Jose, you said yes. And yeah, hardware will fail. So let's say that this host machine is in Walnut, and let's say this machine is in, you know, Taipei, Taiwan, and it fails over. Well, what if there's a fire in Walnut and a tsunami in Taiwan or whatever? If I don't have this data backed up somewhere, even in the disaster. So when we start talking about high availability and fault tolerance, those are great. But disaster recovery means we still need to have a backup somewhere. So this storage API allows our virtual machines to communicate with our backup systems. So these APIs, and the API stands for the application programming interface. And really that's just like the hook that allows the technology to communicate with other technology. So like if any of you've ever done any web programming and you need your web server to communicate with your database server and your database server to communicate with your authentication server, all of those things that allow those that communication to take place, those are known as APIs. Okay, so they're programming interfaces that allow one system to communicate with a totally different system, right? And that can be a challenge in environments where they're mixed Linux and Windows 10 and Windows 7 and all these different things. Some of these APIs can be pretty complicated, but the storage API allows our environment to talk to our backup systems. Okay, so allow vendors to leverage in order to provide enhanced backup functionality of virtualized environments. This enables file level backup and restore, support for incremental, differential, and full backups. Now, we've talked about backups in other courses, right? I know like in the PC servicing, the operating systems, the troubleshooting class, we talk about it, where we define what an incremental, a differential, and a full backup is. But remember, it has to do with the archive bit of the file itself, and whether it changes it or not with the incremental and the differential backups. Okay, so if you're not sure what that's talking about, go back and review that topic. All right, now we can also use our virtual environment with what's known as virtual SANs. And a vSAN is where we can use the storage of our ESXi host and add all that storage together in a vSAN or a virtual SAN. However, the storage has to be solid state. It cannot use SATA or SCSI or IDE interfaces. It has to be solid state. And it maxes out at 8 nodes. So you can only have up to 8 ESXi servers vSAN together with their storage. But this will give you an amazingly fast performance increase, right? So in order to improve input output performance, solid state is the leader in that category. And then if we can virtualize those and cluster them, that's even better for performance. But this does require solid state capabilities. All right, so we've kind of scaled up the ladder here. And now let's say I have my vSphere environment here in Mercedes-Benz USA, and you have your vSphere environment that you're managing over in Tokyo, and somebody else is in Germany or wherever. We're all working for Mercedes. We all have our little environments. But what if I wanted to make sure if my environment, let's say there's a huge fire in Mercedes-Benz USA, and I want everything in my environment to move to Tokyo or move to Germany, right? I wanted that environment to replicate or fail over to another site. That's known as vSphere replication. So this enables customers to replicate VMs from one environment to another environment. So this brings the data replication to, okay, first we talked about a file, then we talked about a VM, then we talked about a host. Now I'm talking about everything. Now everything moves from one site to another. So this means from one data center to another in the event of disaster recovery. So with this vSphere replication, this is literally a $1 million price tag just for this functionality. So whatever else we have, if we want this, it's going to be another $1 million at least. So but companies will pay that. I mean, look at like Amazon or eBay or these companies that have millions of dollars in transactions, right? Per minute, per hour, per day. I mean, what's the cost of losing 1 day of traffic or data? But for certain companies, it's well over $1 million. So for them, let's spend $1 million to make sure that never happens. So for us, it seems like a huge price tag, right? For Mount Sac, that would be an unrealistic price tag. But for a company that, they measured their downtime in dollars, millions of dollars, billions of dollars, whatever it is, that's a huge undertaking, so that they're going to invest in that technology. Okay, there's just a couple more things I want to get to with the vSphere. There's also the flash read cache, where because solid state storage can provide massive number of input outputs per second or IOPS, it can can handle increasing demands. So flash read cache brings full support for using solid state drives storage as a caching mechanism in vSphere. That's kind of like if you move from a regular hard drive, a hard disk drive, to a solid state drive, but you still are using your solid state drive, and for whatever reason you have it configured to use your virtual memory in Windows 10 to use your old drive, if you move that to your solid state drive, your performance is going to improve, right? Just like going from regular to solid state is a huge improvement. The moving your cache will also improve it. So that's part of that. So as you can see, in summary, VMware vSphere is a huge product, right? There are some really powerful features that will change the way you deal with your data center. And VMware is more than willing and more than capable of providing all of these features and functionality. So I feel like I've been giving you a sales presentation, and now is where I ask you to please take out your checkbooks and talk to my assistant, and she'll take your orders for all of your VMware needs. I mean, that's kind of what this lecture feels like, but it really is. There are a lot of things in VMware that you'll run into. So when you guys get hired and some of you end up in these larger environments, we have a former student that is working at Google, and he said, the stuff we learned in CNET is right on. It's perfect, but you have to just multiply that by a couple 100,000, and that's what you're dealing with at Google. Everything's so much bigger, and so there's so much of it that it's just beyond what he was anticipating. So vSphere is kind of that same has that same effect on us. Okay, so what I want to do next is I'm going to just take a little bit of time and talk about Windows Server 2019 and the routing function, and then I'm going to talk also about CentOS server and the routing function, because those are the things we're going to do in today's lab. So it's the top of the hour. Let's take another break, and let's come back at 10 o'clock, so about 10 minutes from now, and then we'll spend a little bit of time talking about Windows Server and CentOS, and then we'll come back and get into the lab shortly after that. All right, let's go ahead and take a short break, and I'll be back in about 10 minutes. Yeah, thumbs up. All right, so in today's lab, we're going to use both Windows Server 2019 and CentOS 8 server, and we're going to create two clones, and they're going to be used as our routers. Now, in our environment, we're only going to, we can have both routers on at the same time, but they're both routing the same network to the same resource. So we're basically going to route our internal network to the external network. So in between will be the router that will take care of that. So I just want to get you a little bit of familiarity with the Windows Server environment, because if you've never seen it or worked with it, it can be a little daunting at first. So the service that provides routing in Windows Server is known as remote access. So routing is under the umbrella of remote access. So remote access in today's environment is super important, right? Because people are working from home, they're connecting to their work environment from home or from Starbucks or from wherever. And there's just a lot of need for this, whether you're traveling, like Gerson on an airplane, or your business partners or your branch offices are in different locations. All of this is an important part of remote access. So some of the features that are available in remote access, we can set up virtual private networking. We can use remote dial-in. Now, remote dial-in, if you're like me, when I first learned about remote dial-in, I thought, that's like an old technology. Why would we use a dial-in modem to connect to a remote network at such slow speeds? But what you'll find out is there's some security of remote dial-in, because we know that a dial-in phone number has a fixed inbound or outbound codec associated with that phone number. So we can set our servers to only allow access from your home phone number. So if you dial in from anywhere else, it will not connect. So from a security standpoint, some of these older technologies provide a little more security. So that's still in the remote access services, remote dial-in, and then routing. And then the one we're going to use today is the network address translation, which is common on routers, right? Routers will translate your network request to the external network's request. So it looks like you're from the outside network. And then there's some web application proxying and some direct access. So the remote access server role has additional features, but the list above covers most of it. Now, again, we can do all of this stuff that we typically do with the GUI interface. We can do it from the command line as well with PowerShell. Now, we're going to have a lab later on in the course where we'll devote all of the lab to PowerShell. So you'll get a good look at PowerShell as well. Now, under the remote access server role, there are 3 roles that we can choose from: either direct access and VPN, routing, or web application proxy. So when we see this, we're going to select routing. And then when that's installed, it will select NAT. Okay. So, and you'll see in the lab that I have those steps kind of outlined for you. Okay. Now with the VPN, that allows our outside users to connect securely where all data traffic is encrypted. And encryption just means the writing, the communication is all scrambled. And then the user is authenticated, which means they are who they say they are. And that will ensure that the communication is both secure and legitimate. So encryption gives us the data security, and then the authentication gives us the that they are authorized and confidentiality. So we get the integrity and the confidentiality. Okay, now VPNs use a tunnel where they will tunnel through a public network, and then the data inside of that tunnel is considered secure, and it will connect your home computer to your business's workspace. And of course, they have to be set up on both ends to do that. If they're using Windows Server, they can use this remote access and virtual private networking and set it up that way. Okay. Now, the tunnel is created by encapsulation, and encapsulation means data is put inside of other data packets. So it's like a package inside of a package. That's encapsulation. All right. So here's our home user, wherever that is, and they're connecting via the internet into our corporate network. So there's the VPN tunnel that's built. So the client's going to have software on it. The server's going to have software on it. Normally, the firewall will be out here, and we'll have to allow access through the firewall, right? Make an exception or punch a hole through the firewall. And then we'll authenticate through the VPN server to our corporate network. And then once the communication is established, all the data that goes through this tunnel is encrypted. So even if somebody out here gets a hold of it, it's useless. They can't do anything without the encryption key to unencrypt it. Okay. And then our user at home will connect, and they can connect to their desktop PC if it's set up that way, or to the file server or the applications that they need. And it's as if they're in the office. So if I were to VPN into my office computer, I could hit print on my home computer. And if my printer in my office is set up here, it would print in my office in Walnut. So on Mount Sex campus, it would print. So it'd print in the stock room where our printer is set up. Okay. Any questions about VPN? No? Okay. Are any of you VPNing into your workplace? Are any of you doing some of that? No? Currently, no? Okay. So, but it certainly is available for that. All right. Now, there's a couple of different tunnel types. There's the point-to-point tunneling protocol, and then the layer 2 protocol, tunneling protocol. The L2TP is a proprietary, another country, yeah, if they have the client software and it's set up properly, if they can get to that network, they could VPN into it, Gerson. Good question. So there really is no borders. I mean, it's not like there are borders. Now, depending on the country, right? If they're in, say, a controlled network environment, like say China, where they may not allow that, but there are underground VPNs that allow them to get access outside of their country. So layer 2 is a protocol that operates at layer 2, which is the data link layer, right? As we learn about the OSI model in networking, we know the physical layer is where the connections are. Layer 2 is where our switches are and MAC addresses. Layer 3 is the networking and routing. Layer 2 is considered a higher level of security than the point-to-point tunneling, because PPTP uses a general routing encapsulation protocol, which is it's secure, but it's not as secure as layer 2. All right. Now, in order to use a VPN, your network, or to do any of these routing features for that matter, we need to have 2 or more network cards installed on our server. So that's one of the things we're going to have to do in today's lab is one, in VMware ESXi, create another network. And then 2, attach another network card to our servers and attach them to that network. So one of them will be connected to the outside network, the other network card will be on the inside. In the middle is the server that will do the routing or the DHCP or whatever. Okay. And the VPN will also do the authentication and the DHCP. All right. Network firewall configuration for a VPN. We're going to have to, on our perimeter network, we're going to have to allow the traffic to come in, and the certain types of traffic, you have to look at different VPN tunnels will use different sockets, right? Different protocols, whether it's TCP or UDP, the traffic type, and you'll want to make sure that you allow that. Otherwise, if we get to this point, everything's set up, we get here, and then it gets blocked at the firewall, we'll never authenticate or never build the secure tunnel. So the firewall has to allow that traffic through. And the general rule on firewalls is to block everything and then allow our exceptions. So we would make an exception for our firewall here. Okay. If the VPN server is a domain member, its computer account has to be in the RAS and the IAS server group in Active Directory. So when we build Active Directory, which we'll do that the first time next week, there'll be some built-in automatic groups that are configured, and RAS and IAS are one of those. So you just have to make sure you put that VPN server in that group. So you move it into that storage container, and then it will take it from there. Okay. So here's the routing remote access server setup wizard. So when we select remote access, the server feature or role, and then for us, we're actually going to connect this, click this network address translation. I mean, we could do VPN as well, but we're going to use NAT for today's router assignment. Okay. And here's some more stuff on VPN. I'm not going to get too bogged down on VPNs because we're going to come back to VPNs later on. But I do want to show the settings for the NAT. So here's using dial-in access. So in Active Directory, we have our user accounts, and we can click on the dial-on tab, and then we can either allow, deny, or allow access through the control access through the MPS network policy. And we can set up dial-in there. So if you're going to use dial-in, you have to enable that. Otherwise, the user will never authenticate. Here's the client. Here's remote dial-in. And I want to get to the part about routing. Okay, so this is the heart of today's lab. So what we need to do, so I'm gonna share another screen. I'm gonna stop this share and I'll open up another program and share screen. So let me share this screen. Okay, can you see this packet tracer on your screen?
Yeah.
Yeah, okay. So I'm gonna just do a little model here of our system. So I'm gonna, here's our computer here, and I'm gonna put a switch, and I'm gonna put a router. So we'll just do real generic stuff here. And this router is actually going to be for firewall D. So this router will be, it's not a physical router. This will be our server, either our remote routing and access server or our firewall D server in CentOS. And then this switch is a virtual switch, which we're going to call VMware internal. Okay, so we're going to build a new switch in ESXi. And then this router is going to connect to another switch, which when we installed ESXi, it created a default switch called VM network. Okay, and then the VM network is going to connect to, yeah, we'll do this here. That represents the internet. Okay, so what our machine, and here's our Windows 10 machine. So this is Win 10, and we're going to clone it and call it client 1. That will be our client machine that we're going to use to test. So this machine is going to connect to this VM internal switch. That switch is going to connect to our router, right, on this side of the network. And then the router, and let me, yeah, there's a way you can change that so it looks like a server instead of a router, but this is our server. Just keep that in mind. And then it's going to connect to this external switch in ESXi that's connected to the internet. Okay, so if this was our configuration and we'd have to wire this up. Well, in our virtual environment, we just go into our settings and tell it what network it's on, and that is like connecting the network. So you want to make sure you get these on the right connection. And in theory, if this machine wants to get to the internet, the traffic has to go through this switch to the router, through the router, which is connected to this switch, which is connected to the internet, right? So there's routing rules, which in routing terms, these are known as protocols. So these protocols are either dynamic or static. We're going to use the dynamic routing protocol for today. Okay, so any questions on this? This is what we're basically going to look at. Now we're going to have two of these. Let me copy that. So one of them will be one server dash router, and then the other one will be CentOS 8 dash router. Okay, so we're gonna do it. We're gonna connect these twice. So first time we'll use CentOS, and this machine will, if everything works right, we'll get internet access, and you'll do a little speed test over here. And then when that one is done, then we're gonna switch and put this one in its place and test it at the same time to test it as well. Okay, so any questions on kind of where the routers are going to come into play? Okay, so let me go back to my share. And when you share the PowerPoint, it always starts at the beginning. Let's get through here. So here's routing. So using RRAS, a Windows server can be configured as a router to connect multiple subnets in a network or connect a network to the internet. So this is what we're going to do, is connect a network to the internet. We're going to connect our VM internal network to the internet by going through our router. And the protocol that Windows Server uses for routing is RIP version 2. So this is a dynamic routing protocol that is included or built into the router. Now, some of you, if you've taken CNET 56 or even the Network Plus prep class CNET62, you probably remember that RIP is only really used in smaller networks. And it's a routing protocol that is based on announcements. So it's going to send an announcement to its attached neighbors. These are my routes, these are my networks. And it does that over and over and over, right? Every 30 seconds is when it will announce that. So this is not a protocol. RIP normally is not found at higher levels of network connectivity, like say an ISP is not going to use RIP, but in internal networks, it's common, very common. Okay, so to configure a router, we're going to select the custom configuration. So here's a topology of our that comes out of this textbook, the Guide to Administrating Windows Server. So here's network 1, which is the 10.10.1 network. So 10.10.something.something network. And over here is a separate network, 10.11.0.0/16. So for those of you that aren't totally familiar with the slash notation, or this is sometimes referred to as CIDR notation, the classless interdomain routing notation, the slash refers to the number of ones in the subnet mask. So /16 means the first 2 octets. So these 8 bits and these 8 bits are all ones. Everything else is zeros. So /16 means there's 8 ones, 8 ones, 8 zeros, 8 zeros. Same on this side. And wherever we have ones in our subnet mask, that refers to the network side of things. Wherever we see zeros, that refers to the host. Okay, so basically what this is saying is, how is this network divided? Well, the first 2 octets are the network ID. 10.10.0.0 is the network ID. Over here, it's 10.11.0.0 is the network ID. If the network IDs are not the same, or in other words, it's saying that is if they're not on the same network, the only way they can connect is with the use of a router. So that's what we're doing here. Now, our network is going to look a little bit different in that this 10.10.0.0 network is going to be on our internal network. It's going to be 192.168.100.0. So that means the first 3 octets are the network ID. And then on our outside network, it's going to be 10.29.72.0, which means this is the 192.168.100 network ID. This is 10.29.72. Those are not on the same network, so we also need a router. And then on this side of the network, it's connected to the internet. Okay, this is kind of flipped around here. This side's on the internet, this side's not. Okay, but that gives us the general idea here. So we need a router. So as you can see, this router needs 2 network cards. Okay, whether this is CentOS or WinServer, it has to have 2 network cards. Our client machine, so this would be like client 1 over here, Win10 client 1, it only needs 1 network card. Okay, so sometimes students get confused and they just start putting 2 network cards in everybody, and then things get, troubleshooting can be kind of complicated. So just make sure you understand the topology before you start clicking next. Okay, So a router is going to build a routing table. So using its dynamic routing protocol, this router will know that this network card is on the 10.11.0.0 network, and this network card is on 10.10.0.0. So any traffic that comes in on 10.10.0 anything and wants to get to 10.11.anything, this routing protocol, the dynamic routing protocol, which is RIP version 2, right? It's going to say, if you want to get from this network to this network, you have to go through the router internally, and it will say traffic on this card is going to go over to this card, and it will send it across, okay, or route it. Now, the table is going to have a bunch of information in it: the destination, the network mask, the gateway, the interface, the metric, and the protocol. So these are terms that really define how the router works. So RIP version 2 will have certain metrics that it'll look at. And the metric, the common metric used for RIP is the hop count, or the number of routers it has to jump through. Now, if I'm talking and you're going, man, it's like you switched into a foreign language talking about all this routing stuff, it's okay for now. I mean, you don't have to be a router expert to do today's lab, but it's just for a completeness that I'm explaining this. Okay. Now, we could do this with static routes, but static routes are only used in very, very small areas. And my experience with static routes is they end up causing more problems than they solve. So it's a quick way to fix a problem, but down the road, when you start doing additional things, that static route is going to bite you. So you need to make sure that you're aware of that, or you do good documentation so that you can figure out what's going on. We're going to use dynamic routing. So we're not going to configure any static routes. We're going to do it all dynamically. And when we click on routing, it's going to automatically use RIP. And then RIP, of course, uses the hop count for determining the best way to get there. Now, in our environment, it's very small. So we only have one hop, right? We just have to hop, boom, across that network to this network, and away we go. If we were to be on a larger network, like say our machine's trying to connect to www.apple.com, it will have to go through multiple hops to get there. And one of the limitations of RIP is it can only go through 30 hops. So if there's more than 30 routers between us and Apple, which I can guarantee you, just to get to Mount Sack's internet, our machine in room 405 is going to go through at least 5 or 6 routers just to get to the internet. And then you go through that, and then getting into Apple's network, there's going to be more than 30 hops. That's why RIP is not used on the internet very often, unless it's very, very small. Okay. Now, the thing we're going to do is we're going to select network address translation. And this is a built-in feature of the routing protocol for Windows Server that will automatically, once we define our local network and our internet network, so it's going to ask us which adapter. Remember, we're going to have 2 adapters in our server. So which one is connected to the outside? Once we select that, it automatically says, well, the other one's on the inside. And it will say, if you're on the inside trying to get to the outside, I'm going to translate your address to an address that looks like it's on the outside, because then that traffic can flow, right? If they're on the same network, they just use a switch. So this is going to allow us to connect to our outside networking. We can also use what's known as port address translation, which allows hundreds of workstations to access the internet with a single public IP address. Okay, so this is using a private IP address to connect to a public IP address, which basically says our internal network connect to our external network. All right. Now to configure NAT, we just select the NAT option in the configuration. For land-based internet access, which is what we're doing, choose the interface connected to the internet in the NAT internet, and then away we go. So here, once we configure NAT, it will say which one of your 2 network cards select, use this public interface to connect to the internet. We're going to click on the adapter that is connected to, and I think in the lab I say, make sure you select the, because they're just going to say network connection 1, network connection 2. Not real helpful, right? Those are default naming conventions in Windows, but look at the IP address. Our internet connectivity will be on the 10.29 network. Our private network will be on the 192.168.100 network. So make sure you select the 10.29 network there. And then you just click next and away you go. Okay, routing remote access can also do web application proxies. So we can build a proxy, and then we can publish applications that are authorized. So some companies will have what's known as a whitelist of applications that are allowed to use the internet. This is how we could do that. We could say, we do not want, if you have any kind of peer-to-peer network sharing, right? We could block that. We could say, if it comes from this application, deny it. If it comes from this application, deny it. Or that's a whitelist, or a blacklist is to block them. A whitelist means allow and then block everybody else. So that's probably the easier way to control traffic flow, is to block everything and then make an exception. Okay, so the rest of this is just talking about that. Then direct access is like an automatic VPN. So we set up the VPN, and then we install direct access on the client. And then whenever they use a resource, so they don't, typically on a VPN, the user has to initiate the VPN connection, and then we'll prompt them for a username and password. With direct access, if I just click on my desktop and I have a link to a resource that's on my corporate network, it will automatically connect to the VPN and set it up. So it's a super good way to make the VPN client connection seamless or invisible to the user. So it eliminates client connection problems. So it's a good way to get around that. And this is only available on a Windows server that's doing VPN, because it uses the technology with the Windows file share to do that. Okay, so in this, you need 2 network cards. The server must be a domain member public IP, and then it's probably going to use the Kerberos proxy for the authentication and encryption. All right, some of the other optional stuff here. You can use the public key infrastructure, create your own internal self-signed certificates, or we can build our own certificate authority in our environment and then use that to sign our own certificates. So we won't get that error that says, hey, you're using a self-signed certificate. Do you want to continue? Right? So there's that. Okay. And the rest of this isn't terribly important for what we're doing today. All right, so today we looked at our sharing, or not our sharing, but our routing. So in CentOS, the routing is a little bit different, and I'm gonna pick somebody here. So I'm gonna bring this over here. I'm going to demonstrate who is there, who would like me to use your server just to kind of do a quick demonstration on some of this. Anybody? I'd use mine, but I already done the lab, so I don't have that capability. So any volunteers? All right, well, let me, okay, Frankie, Alan was the first one to say yes, so I'm gonna use Alan, so 36, so 8-4. So let me share my screen again. So let me connect to Guacamole. This off screen. Let me get my Authy. All right, so I'm going to go to Alan's computer, which is number 4. All right, so hopefully you can see Alan's computer here. And the thing I want to do, so .36 is his server. Conveniently right there, perfect. And what I'm going to do is, if we look at his virtual machines, right? So click on Navigator, virtual machines. You can see he has 3 VMs here. Now, to work with this, and actually, I'm only going to do a little bit of this, Alan. I'm going to leave the rest for you. But one thing we have to do on these machines is on our Windows machines, these 2, we have to do what's known as a sysprep. So sysprep is, it's short for system preparation, right? Again, Microsoft with their great naming convention, they make it really convenient. And what that does is it's going to strip out any unique identifiers so that we can use that same VM multiple times and it won't conflict. It won't say, hey, I'm already on your network. You know, my user ID and group ID is the same as yours. We can't coexist. Well, the sysprep will remove that from that. Okay. So let me bring up today's lab as well. And I'm gonna open this up so you can see it. Don't have it there. Here. This is lab 4. Okay. All right. So here's the Word document. So today we're going to work with our servers, and these parent machines. We're going to have to do what's known as a clone. So we're going to have to clone these. All right. So the thing we're going to do is connect, and then the first thing we need to do is sysprep Windows, our Windows VM. All right. So in order to use it, we have to do what's known as a sysprep, and we're going to do the out of the box experience generalized, and then we're going to select shut down. So I'm going to get this started on Alan's computer. So what you have to do is you actually have to go in to this VM. So we're going to power it on. And we're going to connect in another tab, just like we always do. Now you will not Okay, so looks like yours didn't load properly, Alan. Uh-oh. Let's restart it. Yeah, I'll open the lab here in a little bit. All right, and another thing I want to encourage you to do. This isn't in the lab, but on your Windows machine. So notice how this has a black background. Whenever you're working, because it can get confusing. Am I on this machine? Or am I on my machine, right? And remember, this start button is for my host machine. That's this machine's start button. When you're in the VM, your start button is right here. So it can be easy to get confused. So what I would recommend you do is come into your Windows 10 machine before you clone it and change this background. So go into personalize. And change this picture to a solid color. And then just pick a color that, not black, just, pick something that will kind of trigger you to think, okay, this is not my regular computer. So I'll just do a nice iris green. How's that? Okay. So then in today's lab, what you're going to do is you're going to go into the run. And if you just type sysprep, it'll open the sysprep window. And then I found if you run as administrator, you're going to have better luck. And then we're just going to click generalize and shut down. Now I'm going to show you, you might get an error here. I got an error when I did this lab on my machines. I got an error. Let's see if it gets an error here. Yeah, see right away you get the sysprep tool was unable to validate. If you get that error, here's what we have to do. And this is in the instructions. So if you go start settings and then scroll down to update and security. And then over here, we want to go to the recovery. And we want to do the reset this PC. So what we're going to do is reset this PC, remove everything. And this will go through and basically it's going to remove all the files. Because what happens is on these Windows 10 machines, as soon as it connects to the internet, it starts downloading files from Windows, right, in the Windows Store. And those Windows Store apps they don't work well with sysprep. So what we have to do is do a reset on this machine. Okay. Now we do not have to do this on our our Windows Server machine, only on the Windows 10 machine. Okay, so I'm going to leave that running, and I can close this tab, and it's no problem to do that. We'll show you that it's running there, and I'm going to log out of yours, Alan, because I'm going to let you do the rest. But all of you should be able to get to your machine and reset it. Okay, so let me open up this lab so you can see it. So lab 4, let me publish that. And now you should be able to get to the lab 4. So here's the lab file, the routers and proxies online, and then submit lab 4 here. So that's this file. So you're going to get to this sysprep. So the first thing I want you to do is connect to your Windows 10 machine, connect to your ESXi server, launch your Windows 10 parent VM, try to run sysprep. Now, some of yours may work, but most of you are probably going to get this error, and then you're going to have to go into the reset. So reset this PC and then click remove everything and then next to let it go. And then once it's reset, click on all the setup information that we did last week to create the CNET58 user. So you have to, you know, select the keyboard and all that stuff, create the username and password, and then go through the security questions again. If you don't remember how to do that, look in last week's lab. And then once you're done, run sysprep and it should work. Okay, so let me know. I'm going to stop right here. And once you have this part done with the sysprep on both Windows 10 parent and Win Server parent, let me know. Now you can multitask. You will be able to do the Windows 10 reset and sysprep, and in another tab, open the Win Server and do the sysprep. And make sure on the sysprep, you select this out-of-the-box experience and shut down. That way it will turn off the VM when you're done. And then once those are done, let me know, show me, or just tell me when you're at this point right here. So once you've repeated the Windows Server parent VM, and when you're at that point, let me know. So that means both Windows 10 has been sysprepped and Server 2019 has been sysprepped. There is no sysprep for CentOS. The Linux machine, every time it launches, it's a unique ID. So there is no sysprep for that. Okay, so everybody do part one, and we'll get going there. Okay, so I'm gonna pause this and be around to help you guys get to this next part here. All right.